Yeah, so let's take a look at this. What do we have here? We have a bunch of these. These are probably pathfinding requests that are, or flood fill requests that are running in the thread. So if we, for example, select this thread pool worker, and we go to function list, and we go to game, we can see, yeah, this is pathfinding. Pathfinding here takes quite a while. So these are these little blocks are pathfinding running. But we can see that it's running quite nicely because it is like doing several of these requests. There's still like Slack here available. We have only used like 4 threads for pathfinding. Right? Oh, there's more. Okay, so these are also probably pathfinding. So yeah, the pathfinding is running. The pathfinding could definitely be optimized. We're going to try to optimize it a bit like heavily. So this could be, I think this could be like reduced like 5 times. There's so much, maybe even more than 5 times. Maybe even like to like fraction of the current pathfinding effort of the pathfinding CPU burn could be needed to actually do pathfinding. We will optimize the hell out of it at some point. But now, let's see, what do we have in our main thread? Bootstrap update. Most of requests were very fast, but we had a couple that took, one took 16 milliseconds, one took 13 milliseconds. So a couple of update requests were very slow. I wish I could jump somehow to this slow outlier. How could we do that? How could we jump to the outlier? It's a feature request I would like to get from the people who are making this wonderful tool. Yeah, that would be super useful to have it. But we can see, like, for example, we can just narrow the whole thing down. If we go to Bootstrap update, we can try narrowing it down and see where that outlier lies. So if we narrow this, select update, yeah, it's somewhere in this area. Narrow this, select update. Yeah, there's still that one request somewhere. Narrow that, select update. Okay, so we are out of the zone, so it's somewhere here. We're gonna find that slow request. There we go. So, still somewhere here. And if we lower it, not here anymore, which means it's somewhere here. And yeah, we have this. We have this. Can we try to find and pinpoint which request is still here? Nope. There, you're getting close, getting close. Update 16 milliseconds. Okay, so update, I think we could already find it here. If we look at it. No, it's actually. Let's try and narrow it down. Update. Nope. Update. Yes. I wish this could be automatic. I don't want to do this myself like that. It would be so much easier to just click and focus on the updates. Nope. So probably there. This is our expensive update. Yeah, this is our expensive update. So there are two calls. One of these were 1.3 milliseconds and the other one was 16. I still want to somehow cut it out so we only have that one single update. Yes, we have it now. There we go. So this area here, this range, and we have selected, this range will have the update that takes 16 milliseconds. And we can see where it took the time, which to this view, so you'll see better what I'm doing. Can we zoom in? Yeah, we can. So we can see that like 98% of the time we're spent in clock.tick. So can we actually go in? Can we go in? We can go in here. Clock tick. Yeah, we cannot make these bigger. So, but we can see the clock tick, click that and see that it took, yeah, 16 milliseconds, tick simple, click that. We can see that we are spending lots of time in one signal. And that was the story system. Oh, hey there, story generator. Story generator actually spent these 16 milliseconds to create a new story event. And that started the coroutine. I fucking love this tool. I really love this tool. I actually am so happy that I had a chance to get it. Actually, my friend showed it to me. He used to be a core Unity developer and a very strong C++ programmer. Okay, start coroutine managed. We're still in there. Coroutine run. I want to figure out what is the slowness. What is the slowness here? We're going to dig into this until we get to this module, which is doing pick new. And this is my code. This is my code. Pick new seeded for category. And it's an enumerator. It was calling default story generator is available. It was calling this method. And that method call took 10 milliseconds, which is way out of its time. And it seems that it was doing check preconditions, which was expensive. Has food on device. Oh, so that's what makes it slow. So we can already see, and also is egg available. And these two happened in one frame. So we can already make a huge improvement just by going into this pick new seeded for category. Pick new, oh come on, Control T. Pick new seeded for category. Default story gen. There. It's an enumerator. So what I'm doing wrong here is this. There is this for loop. We're going through all the events. And we're calling this is available. And after that, we have this frame timer has to yield. So this frame timer has to yield. I thought that it would be nice to have a it doesn't, this thing doesn't work well. Yeah. We have to have some different way to do this because this has to yield. How it works. Yeah. No. Let's not do that. Let's not do that. Actually, we have something different for this. We have something better. Game timer. Frame budget. Has available frame budget. We have this, which is probably going to be much better. Frame duration milliseconds. Yeah, we should use this one. If has available frame budget, or you know what? Actually, there is another thing we could do here. But I will still do this. I'll still do this instead. Yeah, so we're just gonna do that. Yeah, so that will already make it much better. And see how cool it was to like drill into the code here, drill into the performance metrics and find the bottleneck. So the bottleneck that was that we have two expensive story events, which are checked. Like, do we have any food on the device, and do we have something like a egg that could be spawned? And you know what? I'm actually also not gonna leave it at this. We can do better. We can make it even faster, because those precondition checks on food, on device story event, we can just look into it and see what's slow in there. And we're doing this tile transfer component for each multi, which is horrible. Let's go into this find food on device story event and see as food on device. Check. Yeah, has food on device. That's the thing. So first we get all the slots, and then we're doing this. This is what costs a lot, because we're doing this. First of all, slots here. Yeah, we're having a lambda, which actually also produces garbage. And then we get the first object in position for each multi. We're checking if that thing is a pile, and if it's a pile, if it's a food or not. I guess what we could do instead, we could do this in reverse. Instead of going through all the... Yeah, instead of going through all the items that are in the map. No, but wait. Slot. I don't like this for each multi. What does it do? Yeah, we use it quite often. Okay, so we have this for rotate and then do a callback on each. Okay, that is not nice. That is not nice. That is not nice. Yeah, so this thing lasted 4 milliseconds. 4 milliseconds is a like insanely large amount of time. Insanely large amount. What could we do to make it quicker? Does look great. Gives me a headache remembering how I had to profile C and C++ back in the day and use a gprof. Yeah, good tooling is actually very nice. Good tooling is important. Good tools are saving you time. But now let's see, what could I do about that? If it's an object slot, slot type, slot entity style, find first in position. We're doing a lot of unnecessary stuff. I think it would almost easier be to just find all the food that is in the map and check if the food is on top of a device that is flammable. Yeah, how about we rewrite this? But I actually want to, since this is an expensive operation, I would like to somehow profile it. Yeah, I would like to profile it. So I'll keep the original implementation. This takes 4 milliseconds in a big map. What can we do? So first of all, we need to find all the food. What is food when it's spawned? It is something like bread. Object meals bread. It is a base meal. Base meal has just an unstored material. Okay, so it's just an unstored material. In the early game, we will have shit ton of unstored materials. So I'm not really sure if it's a great way like to look through all those, unless we could do something as system inventory, find, or maybe find storages. Containing, no, that's gonna be increasingly complicated as soon as we get more food. But you know what? I'm actually thinking that we could just tweak this a little bit, because this type is object. Slot entity is tile. Yeah, power true. Makeshift. We're looking at all makeshift slots. So that actually doesn't look super expensive. Unless we could maybe somehow... could we maybe do this? We could... No. Damn it, this is harder than I thought. I mean, we could of course cache the fact that the food item is near the device. Like when the device is placed near the object, we could detect that and then have some kind of cache. But I don't think that this is a nice solution. Again, this is where the region system would actually come into play very nicely. The region system would do a thing where we could just find the slots, get the region, and check the radius, and that would be just fine. You know what? I'm not sure I could optimize this right now. Unless I could, you know what? I could do one thing. I could maybe do one thing. Instead of doing this for each multi, I guess what we could do is we could implement an alternative method for looping through the tiles, looping through the subtiles. We have this rotated width, rotated height, and then we have this for loop. So we could make a public int, which would return a position, and we could call this maybe subtile position at, or maybe subtile position int subtile number. So if not is multi, we're going to always return position. Index plus IDX if it's not multi. Otherwise, we're going to do a very simple thing. Int I equals, or wait, you know what? Oh, no, there is a better way. We could pass in, we could have something like get sub tile positions, and we will pass in a int array cache, and we will do, if not is multi, we will set the cache 0 equal to pos idx, and we will return 1. So it will return the size of array, or the number of positions. So yeah, there's one position, it will be going to the first one. And otherwise we're going to do this for loop, and we're going to have like int index. We'll start with 0. And we will do, instead of callback, we're going to get this neighbor, like p equals this, and we're going to do cache idx plus plus equals p to put the position in. In the end, we're going to return idx. And that will be so much more efficient than this lambda shit that I was using all the time. So maybe I could actually do obsolete, replace with get subtile pos. And there's two methods. Hey, slept your dev, do not switch to your right monitor. Oh, I'll try. I'll try to not rickroll myself. So now we are going to do this. T transform get subtile positions. We will pass the caches pos idx, which will be an array of ints. And we will get like var num pos equals that. And then we're going to do for each. No, actually for int I equals 0, I less than pause, I plus plus. And we're going to get the objects, find first in position, and we will pass the caches pause idx I. And the rest will be maybe if object.pile is not null, we could do object could be null, yeah. So object question marks pile question mark group ID equals mad group dot food. This is food, so we're gonna do this. Found device, last found meal, and we're going to maybe break out of this for loop. And after that, we could do if found return true. So yeah, we basically eliminate this expensive lambda for each nonsense in exchange of a simpler approach. That will already have a much better result in terms of performance. But can we go further? We had more. Is egg available? Is egg available? Oh wait, it was just 0.12 milliseconds. This is nothing. Most expensive part was this for each multi. We could actually search for each multi in the whole. Oh wait, before I do this, I want to actually clear this and analyze this frame a little more. A little more. Game update. Okay, so system story gen. Create the new main event is available. Check preconditions. Story event meta get what? Load object. Oh, so we were reading. Oh, but this was happening like for the first time. Okay, okay. So we haven't really preloaded everything. So we loaded the object. And that was also part of the cost of this frame because we took 2.3 milliseconds to read the disk because we lazy load the configuration. And that happened in check preconditions. So check preconditions. Two references is available. Is available. Random story generator has this, and yeah, we have this has to yield. We are going to replace that in the same way. So yeah, is available could be expensive. That is the thing. This is new expedition story event. Oh, it's even worse. Oh my god, it's even worse because I'm gonna have to return to this. And I'm gonna have to return to this. Yeah, we want that in random story event instead of this. Yeah, we don't want to hold here forever. But also there was this expedition event in story in the default story generator expedition new expedition event. So it's a virtual, but I hate that it has the for loop which could be very expensive when we have more events, and it's just a like we're ticking the expedition stage. Yeah, that's not gonna fly. When do we tick the expedition stage? Oh, that will have to be changed someday. Yeah, expedition could be expensive when we have more story events. Hey, tomato salad. I'm lurking, but if you want to profile a certain piece of code, and profiler begin sample and profiler and sample can help. Yes, I use that all the time. I even have my own class which wraps it into p dot something, but I have a better tool now. I have this Superluminal, which allows me to dig deeper and analyze things as if I would be doing deep profiling, but without the performance overhead. Well, with very little performance overhead. And it's freaking fantastic. I mean, I can debug, I can profile the build while it's running. I can profile the build that is running from Steam. And I can get like everything. I can see everything. It's just fantastic. Okay, so check preconditions. I think we tackled this a little bit. Let's expand this whole area, and I want to see check preconditions. Okay, it was expensive. Then we have the component data. It's not even in the list. It's not even in the list. Unless there's some... No. So the answer is that it's probably not worth pursuing. Yeah, if we look at the dictionaries in this range of almost 30 seconds, dictionary operations were taking very negligible. Very negligible amount of time. Pick new seeded. Dictionary add. The only other thing I'm missing here is how many invocations were there. Oh, 2. There were 2 invocations. Ah, wait a minute. I think I wasn't looking well enough here. Component data. There we go. Get bool. Oh my god. It is worth doing it. Component data get bool was invoked 161 times and total time is 18 milliseconds for something like a lookup of a variable. This is freaking insanely big amount of time. And also we have this dictionary extensions get call. Dictionary extensions get, but this is aggressive inlining. So maybe that's fine. But this is not cool because, yeah, because we have to We have to do something with it. We have to do something with it. Get bool. It's called from story event is ended, story event is started. Oh my god. Oh my god. This is horrible. This is horrible. I have to rethink how my story events are saving and loading data, because starting and loading is ended is started. These things are called all the time. Yeah, we have this is started is ended. Oh my god, this is actually horrible. I guess we will do two things here. Private bool has is started cache. It's just going to be temporary workaround. Private bool is started cache. And we're going to do this. If we want to get is started, we're going to do if has is started cache, return is started cache. Otherwise, we're going to do is started cache equals that, and has is started cache equals true. Now, when we set something, we will do we will do this set bool is started and started cache equals value as is started cache equals true. Yeah, so we need the same thing for wait. Return in started cache. Yeah, we need the same exact thing for is ended. That will also be called 100,000 times. So for those who like writing beautiful code, I know you want to cry when you see stuff like this, because I do. But there's beautiful code and then there's fast code. You have to choose which one you want. All right, so this will hopefully reduce the strain of those requests.